This video is going to demonstrate the area model for multiplication and division algorithm. Just as a quick reminder on base 10 blocks, the base 10 blocks, we know that these little squares are called units, and a 1 times 1 is 1, or a unit times a unit is a unit. And as we look across this kind of traditional multiplication chart, that you have all these units times a unit gains these units. And so once you get to 10, you get 10 units right here. And you can actually combine 10 units into one rod. And we have these 2 units left over. So really you can have one rod with that group of 10 and 2 units. And we'll show that right here. Here's that group of 10 units as one rod. And then we have over here the 2 units. And so as we slide all this down, we can have 10 times 1 is 10, and then 2 times 1 is 2. And so we want to be thinking numbers in base 10. That's the whole premise behind base 10 blocks. So a unit times a rod, or 1 times 10 is 10, or a unit times a rod is a rod, and likewise over here. So the number 10 really means 1 rod and 0 units. And the number 12, which would be this stretch right here, represents 1 rod and 2 units. And those simple ideas of a unit times a unit is a unit, or a unit times a rod is a rod. Moving forward, here's just another graphic of how that could look like. Rod times a unit is a rod, etc. As we go on to this next type of area model, you can expand it as we have the value going across the top is 2 rods and 5 units. So a unit times 2 rod and 5 units gives you that amount, that same amount going across. And so as you expand this, a rod times 4 units is going to give us 4 rods. A rod times 4 units gives us 4 rods. And 5 units times 4 units gives us 20 units. And so we're just building this conceptual pattern. We can change the terminology from rods to units. And so from rods and units to tens and ones. And so the same diagram, but now we're using numbers. As we use the numbers, there can be some subtleties that start to shift. And so instead of having 2 groups of 10, we can start grouping these into 20s and 5s. And so kids can apply their math facts that way, and they can start conserving a little bit of space, maybe a little shortcut, so to speak. And instead of multiplying 4 times 10 and then 4 times 10 again, now you can go 4 times 20 and get these values, and 4 times 5 and these values right over here. Another way of just kind of subtly moving forward to it is that we're actually just kind of now, instead of having these rods a little separated here, I know this is a subtlety, we're actually just going to combine them all together, and we now have our first truly rectangle with a grid in it, but the value is still the same. 4 ones, 2 tens, 5 ones still gives you the same value in here of 80 plus 20. Now, as we move forward, yet again, we can then take this value here, or this diagram, and start looking at this in terms of just 10 times 4 is 40, 10 times 4 is 40, and 5 times 4 is 20. We're starting to look at the area of the rectangle in a more holistic sense, rather than looking at it in these these rods and units. So again, a very subtle shift, but we now have this area. 10 times 4 is 40. We understand it. We don't have to have the outline of the rods anymore. And with some more subtle shifts as we move along, we now have, instead of 2 groups of 10, now we have 20. 20 times 4 is 80, and 5 times 4 is 20. And you can probably predict what the next one is going to be, which is the entire length, which is now 25. 25 times 4 is 100. So why is this all important? Well, it does give us a good physical replication, or a picture replication, of what multiplication is in terms of area. But let's take a look at this problem. What if we started with 258 as the area of a rectangle, and we knew that this side was a 6? The question becomes, what is the length of the top side? Well, we want to think in tens. We worked on tens back here with the rods, etc. Earlier, we had a lot of rod work with tens, and so we want to do the same thing here. We don't want to lose that previous knowledge. We just want to think in tens. And so the big idea as we work through trying to figure out what is the length of this side, Let's think in tens and focus on what you know. And so, well, what do we know? We know this. We know that 6 times 10 is 60. So if we know 6 times 10 is 60, this area of our array is worth 60. And then this area over here is 258 minus 60 equals 198. Just to give you a recall, again, we started out with the area of this rectangle being 258. So that's a number you want to anchor to your brain right now as we move through it, and the 6 on the side. So when we did our first problem, we saw 10 times 6 is 60. So 258 minus 60 is 198. So this value of the rectangle is 60. This value is 198. The area is still 258. And we're just going to do a little bit of subtraction over here as we move along, because we did start out with 258. We're going to subtract 100. We'll subtract 60, and we now have 198. Now let's continue. Well, what do we know? We know that 10 times 6 is 60. Remember, our quest is to get to this whole length, and so we're going to focus on what we know in tens. And so we just do this move again. 10 times 6 is 60. It was 198. So 198 minus 60 is 138. Again, here's 60, there's 60, here's the 138. We're conserving the area of 258. So now this block is 138, and we're just keeping score over here. You're probably starting to predict our next patterns. Again, we know that 10 times 6 is 60, and we segment this rectangle off again with a 60. 138 minus 60 is 78, which is this component of it. Again, if we look here, we're conserving the area of 258. We're just keeping score on the right with that repeated subtraction. And you predicted, I'm sure, the next move. 10 times 6 is 60. That's that area of the rectangle. What's left over is 18. Conserving area, 258. And now we just deal with 18, and it's 3 times 6 is 18. So if we wanted to know the length of the side, we basically have it right now, because our question really is, how many groups of 10s do we have? We have 4 groups of 10, which makes 40, plus that 3 is 43. So the length of this side is 43. As we were keeping score over here on the right, notice we have 4 groups of 10s that we're showing as we had this repeated subtraction happening of 60, and then 3 groups of 3 times 6 is 18, subtracted there again. So this length is 43. So students primarily are focusing on the tens on segmenting the rectangle. And so what is the length of the side? It is 43. So let's go back. We're going to start again. Suppose that we're back to that same problem. We're going to think in tens again, but we don't have to think in just 10. What if we thought in 20? So 20 times 6 is 120, and this area is 138. So again, we're focusing on what we know. We know tens, 10, 20, 30, 40, 50. We know those. And so we're just going to segment this off. And so we're going to start off with 20 times 6 right now is 120. This is 138. The area is conserved again at 258. So the subtraction over here, keeping score against 138. You're going to notice this pattern as we move along. We're going to do 20 again. Here's the same type of pattern happening. We're subtracting 120. There's that 18. You're probably predicting that that's going to be a 3. We're conserving area. And sure enough, you did a great job. That's going to be a 3. And so what is the length of that top side? Well, what is the length? It's 43 again. But we got there a little differently, because instead of just going 10 times 6 and 10 times 6 4 times, we did 20 times 6 twice, and we're able to get the same answer. We still had 4 groups of 10 and 3 groups of 1. So students can move from focusing on just 10 times a number to now like 20 times a number. What if we started this problem again, and then this time, instead of guessing 20, we guessed 30? You're probably seeing where we're leading this to. So 258 minus 180 is 78. That's this side of the rectangle. Still, the entire area is 258. So we move on. We segment that 78 out to a 60. So 10 times 6 is 60. We're leaving that as 18. Just keeping score over here. And then finally, we have a 3 at the top. And so notice that we still end up with 43. That's 30 times 6. That's 3 groups of 10, 1 group of 10. So how many groups of 10 do we have? We still have 4, which is a total of 40. And groups of 1, it's 3, still 43. So as we get towards the final stages of this video, we're going to notice that this is still 43. We just got there by, first pulling out an area of 180, because that was 30 times 60 and then 10 times 60. So what would make most sense if we were to ask this problem again, what is the length of this side? And if you had to go to recess right away, you probably aren't going to guess 10. You're probably going to guess 40, because 40 times 6 is 240. So you get 258 minus 240, you receive 18. So you know what's going to happen next, which is going to be that 3, 0. And now, how many groups of 10 do we have? We have 40. How many groups of 1 do we have? We have 3. And so that length, again, is 43. So here's the connection between the area model for multiplication and division with the standard algorithm. So we're going to put in that divisor sign, put the 6 out there, and go through our procedures that we learned going to school. 6 going to 2, no. The 6 going to 25, sure does. There's the 4. So we get the 4, but notice the 4, we've been taught to write that in the tens column because it's really going to 25. But what that 4 represents is 4 tens, and the basis of that move is right there with the 40. We already knew that was going to be 40 from the work we did with the area model. And now we just continue on with the 18 to deal with. 6 goes into 18 3 times. We got 8 and subtract 18, 0. So we're done over here. There's the 3 again. So a beautiful connection, folks, between the area model for multiplication and division and the standard algorithm for division. So a student conceivably can work from the conceptual side and intuitively understand the algorithm for division.